Jai Hind students, I hope you all are in very fine state of mind. So in today's lecture, we will discuss about momentum. Because Newton's second law of motion, it's based on the concept of time rate change in the momentum. So in order to understand second law of motion, we need to first make ourselves familiar with this particular physical quantity, which is known as momentum. So let's start with this particular topic. First we'll discuss it qualitatively and then we'll discuss it quantitatively. Student, this property or rather this physical quantity momentum is associated with any moving body. Now look, when a body moves, then the impact of a moving body is measured by this physical quantity, which is known as momentum. So theoretically, momentum of a moving body is defined as the net or the total amount of motion contained in a body. So momentum actually is the total or the net amount of motion contained in a body. Now, total amount of motion contained in a body can be represented by two quantities, the mass of the body as well as the velocity of the body. So in order to understand or in order to measure the impact of motion or impact of a moving body, we need to include both the terms mass as well as velocity. So quantitatively or mathematically, the momentum of a body is defined as the product of the mass of the body and the velocity with which the body is moving. For example, suppose this is a body, say of mass m, and suppose it is moving with velocity v. Then its momentum is given by mass into velocity, and momentum is represented by small letter p. This is the notation which we use for representing momentum, right? So again I repeat, qualitatively or theoretically, momentum of a body is defined as the net amount of motion contained in the body. And mathematically, the momentum of a body is defined as the product of the mass of the body and its velocity. Now look students, mass is a scalar quantity, velocity is a vector quantity having direction. So momentum is also a vector quantity having both magnitude as well as direction. So momentum is a vector quantity. Clear students? And also regarding its SI unit, the SI unit of mass is kg, while the SI unit of velocity is meter per second. So the SI unit of momentum is kg meter per second. In CGS system, the unit would be in CGS system. CGS, as you are aware, it's the unit where the length is measured in centimeter, the mass is measured in gram, and the time is measured in second. In CGS system, the SI unit of momentum is, in place of kg, mass will be measured in gram. In place of meter per second, the velocity will be measured in centimeter per second. So this is the SI unit of momentum and this is the CGS unit of momentum, right? So momentum, remember, it's a vector quantity having both magnitude as well as direction. Clear students? Now we will discuss all the various possibilities and try to discuss it in detail. We'll discuss every minute things, right? So this is the actual formula. Momentum is given by mass multiplied by velocity. So let's discuss all the cases. Now let us consider for a given body. Let's consider first case. For a given body. For any given body, its mass is constant. So for a given body, mass m is constant. For any given body, mass is constant, isn't it? Therefore, momentum would be directly proportional to its velocity. What I mean to say is that a body when moving with low speed will possess small momentum. And if the same body is moving at greater speed, it will possess large momentum. So body moving at greater speed possesses large momentum, and the body moving at slower speed will possess small momentum. So if we plot a graph between P and V, they are linearly dependent. With the increase in the velocity of the body, the momentum of the body will also get increased. So if you show the variation of momentum with velocity, so the graph would be like this. This is P, this is V. If the velocity of the body becomes zero, that is if the body is at rest, then the momentum of the body is also zero. So momentum is a term associated only and only with a moving body. To possess momentum, the body must be in motion, right? So, in case velocity is made twice, the momentum of the body will also become twice. If the velocity of the body is made 3 times, the momentum of that particular body will also become 3 times. So, for a given body, the momentum increases linearly with the increase in its speed. So, therefore, the graph obtained will be like this. It will be a straight line inclined towards the horizontal, right? Passing through the origin. So this graph shows the variation of momentum with the velocity of a body for a given mass. Here mass is constant. So P is directly proportional to V. Is it clear, students? Now consider case 2. Now we will consider the case of 2 different bodies, right? Having different masses but moving with same speed. Suppose this is body A and let us consider this to be body B. Both are moving with speed V. But masses are different. M1 is less than M2. Now since P is equal to mv, here we are considering the velocity of both the lighter as well as the heavier body to be constant. So since V is constant, therefore it implies that P is directly proportional to M. This is the symbol for proportionality, right? Proportional. This is read as momentum is directly proportional to mass if V is constant. What I mean to say is that if 2 different bodies, the lighter and the heavier body, move with the same speed, then the body having larger mass will have large momentum. The lighter body having small mass will have small momentum, right? So this is the thing. In case V is constant, then momentum is directly proportional to the amount of matter contained in the body. Clear, students? Now let's consider the third case. If we consider 2 different bodies and suppose they are having different masses moving with different speeds, but if those 2 bodies possess same momentum, then let's see what happens. What are the things which we can conclude from this? Suppose these are the 2 bodies. This is body A of mass m1 moving with velocity v1. This is body B of mass m2 moving with velocity v2. And their masses are different, their velocities are different. Suppose here P is constant. P is constant means suppose both these bodies possess the same momentum. What is the momentum of this body? It will be equal to m1 v1. What is the momentum of the second body? This is for the first body and this is for the second body. It will be m2 v2. Now since both the bodies possess the same momentum, therefore you can equate these two. Since PA is equal to PB, therefore m1 v1 is equal to m2 v2, or v1 by v2, it would be equal to m2 by m1, or V is inversely proportional to the mass, isn't it? So what do you conclude from this, students? If 2 different bodies having different masses moving with different velocities, but if they possess same momentum, so in that case we conclude that the heavier body must possess smaller speed, it must be moving with low speed, while the lighter body must be moving with greater speed. It is only then that the momentum can be equal, right? So lighter body must be moving with great speed and heavier body must be moving with small speed. That is the condition for the two different bodies to possess same momentum. Clear, students? So these are the things which we can conclude from the concept of momentum. Now let's discuss the change in the momentum of a body and try to find out what does the quantity, the change in the momentum, or rather the time rate change in the momentum represents or signifies. So what we do is, let us consider a body A of mass m to be initially moving with velocity u. Initially means at t equals to 0. Initially means at t equals 0. When we start counting the time, isn't it? So initially, suppose this body A of mass m is moving with velocity u, right? After some time, the mass of the body, it's a constant quantity, it will remain same. The amount of matter contained in the body always remains same, isn't it? So, this is the same body, but after some time, suppose under the influence of this force, this is the external force acting along the direction of motion of the body. So students, what will be the effect of this force on this body? This force will definitely make the body to increase its speed, isn't it? If this force was acting in the opposite direction, then the force would have retarded its motion. But since in this case, we have assumed the force to be acting along the direction of motion of the body. So this force will make the body to increase its speed. So under the influence of this external unbalanced force, suppose the body after some time acquires a final velocity v. Now student, look, here I have represented the velocity with an arrow of longer length. Longer length represent the magnitude of the velocity is much large as compared to this case, initial case, right? So this is after time t. After time t equals to t. So what is the time that has elapsed? What is the time after which the body, it is able to change its velocity from u to v? That is time t. Time that has elapsed is t. T minus 0, that is t. So after time t, the body is able to change its velocity from u to v under the influence of this force F. So this is the intro, right? We have considered a body of mass m to be moving with initial velocity u. Under the influence of this force, which is acting along the direction of motion of the body, let after time t, the body acquires a final velocity v. So therefore, what will be the initial momentum of the body? The initial momentum of the body would be, let us represent it by pi. I stands for initial, right? Momentum is quantitatively given by the product of mass and its velocity. So initially, its velocity is u. So mass multiplied by velocity. Clear, students? Final momentum. The final momentum of the body is, final momentum may be represented by Pf. F stands for final. P is used to represent momentum. So what is the final momentum of the body after time t? Again, it is given by product of mass and the final velocity, which is v in this case. Clear, students? This is the initial momentum of the body and this is the final momentum of the body. So, therefore, change in the momentum of the body. Change in the momentum of the body. What is change? Change in any physical quantity would be the difference between the final value and the initial value. Final minus initial, that is the change. So change in momentum would be the final momentum of the body minus initial momentum of the body. So substitute the value. So we'll get mv minus nu. So what we get is mv minus u. This is the change in the momentum of the body, right? Now, time rate change in the body. Time rate change in the momentum of the body. Time rate change means the change in the momentum per unit time, right? So, time rate change in the momentum of the body would be the change in the momentum of the body, which is mv minus u divided by the time during which this change has taken place. So, what is the time that has elapsed for the change in the momentum to take place? That is t. T is the time that has elapsed. Again, I repeat, students. This is the initial momentum, this is the final momentum. Change in the momentum would be equal to the final momentum minus initial momentum. And time rate change, time rate means the change in the momentum of the body divided by the time during which that change has taken place. The time taken by that change to happen. So, change in the momentum divided by the time, that will give us the time rate change in the momentum of the body. Clear? So, this is the time rate change in the momentum of the body. And students, as per Newton's second law, this time rate change in the momentum of the body is found to be directly proportional to the external unbalanced force. And the change in the momentum is found to take place along the direction of the force applied. Now here we are dealing with one-dimensional motion. So no need to represent the direction because the body is assumed to be moving along a same straight path, isn't it? So force is directly proportional to the time rate change in the momentum of the body. This is as per Newton's second law. So what you get is, force can be represented by F is proportional to M V minus U divided by T. Now students, you remember V minus U by T, that is the time rate change in the velocity of the body. And time rate change in the velocity of the body is known as acceleration. So what we can do is, we can write it as F is proportional to M, V minus U by T is acceleration. A is acceleration, which is V minus U divided by T. It is the time rate change in the velocity of the body. So in order to eliminate this proportionality sign, we need to introduce some constant. So what we do is, F is proportional to MA. Therefore, in order to eliminate this proportionality sign, we need to introduce some constant. So it is KMA. K is any constant of proportionality. Now, the units of M, A and F are so chosen that the value of K is taken to be unity, that is 1. That is, if the mass of the body is measured in kg, acceleration is measured in meter per second square, force is measured in Newton, then the value of K is found to be 1. Now since the value of K is equal to 1, therefore F is equal to MA. This is the mathematical form of Newton's second law of motion, and according to which force acting on a body is given by the product of the mass of the body and the acceleration produced in the body. So this is the mathematical form of Newton's second law of motion. Right, students? Before we discuss about this thing, F equals to MA, let me repeat this statement, Newton's second law. Newton's second law concerns with the concept of momentum. So according to Newton's second law of motion, it states that the time rate change in the momentum of a body is directly proportional to the force applied. Which force? The external unbalanced force applied. And the change in the momentum of the body takes place along the direction of the force applied. So that's the perfect statement of Newton's second law. And using Newton's second law, we have concluded this particular mathematical statement, which is F equals to MA. This is the mathematical form of Newton's second law of motion, in which the force is given by the product of mass and acceleration. So students, Newton's first law that deals with the concept of inertia. Newton's second law that gives us a method to measure the force which is acting on a body. It concerns with the time rate change in the momentum of the body. So by measuring the time rate change in the momentum of a body, we can measure the force acting on that body. Clear, students? So now let's discuss this term, F is equal to ma. So mathematically, the external unbalanced force which is acting on a body is given by the product of mass of the body and the acceleration which is produced in the body. So this is very, very important formula. This is a very, very important formula. Force is equal to mass of the body multiplied by acceleration. That is, F is equal to ma. Right? So again, let's come to this particular thing. What we do is, this is a small mass, lighter one, and this is a heavier one. And same force is applied over here. Same force is applied over here. This is of mass m1, this is of mass m2. m2 is greater than m1. So in which case, more acceleration will be produced? Obviously in the lighter one, isn't it? So here, it will produce acceleration in it, and here also it will produce acceleration in it. If the body was initially at rest, it will start moving. And as we have discussed in the previous session, the greater the amount of matter content in the body, the larger the mass of the body, more will be the resistance offered by the body towards any change in its state. Isn't it? So mass gives the measure of the inertness of a body. So here, which body is more inert? The heavier one. And thus, to increase its speed or to change its state, much larger force will be required in the case of heavier body. In this case, what we have considered is, in both the bodies, same force is applied. So we want to check in which body more acceleration is produced. So, considering this, since F is constant, therefore, m1a1 would be equal to m2a2. Suppose a1 is the acceleration produced in the lighter body, a2 is the acceleration produced in the heavier body. Therefore, a1 by a2 would be equal to m2 by m1. a1 by a2 would be greater than 1 since m2 is greater than m1. This is heavier body, this is lighter body. Therefore, a1 is greater than a2. So what does it suggest? If the same force is applied on two different bodies, one of lighter mass and the other one a heavier mass, then the force will produce a large acceleration on the lighter body. Isn't it? The lighter body will get accelerated through greater amount. So that's the first concept. So lighter body, because of the fact that it has got lesser amount of matter, so it will offer small resistance towards any change in its state. Isn't it? Therefore, on application of force, it will readily tend to change its state, or it will readily tend to change its speed. So on applying same force on two different bodies, the lighter body will get more accelerated as compared to that of the heavier body. So that's the first conclusion which we can make from this particular equation. Right, students? So this also suggests that, second one, this also suggests that if a force is acting on the body, then the body must be having some sort of acceleration. Right? If F is 0, then acceleration is 0. But if F is having non-zero finite value, then A will also have non-zero finite value. So it is the force which produces acceleration in the body. So it is clear that if a body is in accelerated motion, then some net external unbalanced force must be acting on it. Must be acting on the body. This is a very, very important conclusion. Whenever a body is in accelerated motion, it clearly suggests that some force must be acting on the body. Clear, students? Even if a body is moving along a circular path with constant speed, still it is changing its direction continuously. So it is the case of accelerated motion, and in the case of accelerated motion, some force is acting differently on the body. And in the case of a circular path, that force is known as centripetal force. Isn't it? So whenever a body is in accelerated motion, then some net force must be acting on the body. On the contrary, if the body is in uniform motion, look, if the body is in uniform motion, then A will be 0. A body moving in uniform motion means its velocity is constant. If velocity is constant means acceleration is 0. And if acceleration is 0, then force is 0. So, if a body is in uniform motion, that is when acceleration is 0, it will be the case of uniform motion. Then F would be equal to 0. Then no net external force acts on the body. So that is what we have discussed in the earlier session as well. If a body is in uniform motion along a straight line, then no net force acts on the body. Net force acts on a body only when the body is in accelerated motion. And for a body to have accelerated motion, there can be 3 cases. Either the speed of the body may change, it may either increase or decrease. Second, its direction of motion may change. And that is the case when a body moves along a curved path. Its direction of motion changes continuously. Right? That is when the body can have accelerated motion, and that is only under the influence of some external unbalanced force. Clear, students? Now, we need to discuss its SI unit as well. So what we do is, SI unit of force is, students, as you are aware, it is Newton. It is after the name of famous scientist Isaac Newton. So SI unit of force is Newton. Let's try to define Newton. So SI unit of force is Newton. And 1 Newton, it would be equal to mass, SI unit of mass is kg, and SI unit of acceleration is meter per second square. So 1 Newton is kg meter per second square, right? So how do you define 1 Newton? 1 Newton may be defined as that force which, when applied on a body of mass 1 kg, is able to produce in the body an acceleration of 1 meter per second square, right? So suppose this is a body of mass 1 kg, and on applying force the body gets accelerated by 1 meter per second square. Then the force acting on the body is said to be 1 Newton. I'll repeat this. The force acting on a body is said to be 1 Newton when this force, when acted upon a body of mass 1 kg, produces in it an acceleration of 1 meter per second square. Clear, students? So SI unit of force is Newton. Its CGS unit is, CGS unit of force is dyne. D-Y-N-E. CGS unit of force is dyne. CGS, as I've told you, it's a system of unit in which the length is measured in centimeter, the mass is measured in gram, and the time is measured in second. So 1 dyne, it would be equal to, in place of kg, in SI mass is measured in kg, in CGS mass is measured in gram, so it will be 1 gram. And in place of meter, distance in CGS is measured in centimeter. Time in both these systems is measured in second only. So we get 1 centimeter per second square. So this is the CGS unit of force. 1 dyne is equal to 1 gram multiplied by 1 centimeter per second square. How do you define 1 dyne then? The force acting on a body of mass 1 gram is said to be 1 dyne if it is able to produce in the body an acceleration of 1 centimeter per second square. Clear, students? So this is how you can define 1 Newton of force as well as 1 dyne of force. Now let's find out the relationship between these two, right? So let us find out the relationship between SI and CGS unit of force. Let us find out the relationship between SI and CGS unit of force. So let's try to get the relationship. 1 Newton, just now we have discussed, it is 1 kg multiplied by 1 meter per second square, right? 1 kg, as you are aware, students, it is equal to 1000 grams. So it is equal to 10 raised to the power 3 gram. 1 meter, it is 100 centimeter. 100 centimeter means 10 raised to the power 2 centimeter per second square. Now if the base is same, then the power get added up. So what you get is 1 Newton is 10 raised to the power 5 gram centimeter per second square. And students, gram centimeter per second square is known as dyne. Therefore what you get is 1 Newton is equal to 10 raised to the power 5 dynes. This is a very, very important relationship. Newton is the SI unit of force, while dyne is the CGS unit of force. And the relationship between this is 1 Newton is 10 raised to the power 5 dyne. Right? So students, I hope you understood the concept of momentum. So let us recapitulate it. Momentum is the total amount of motion contained in a body. And the impact of a moving body can be measured only by having the mass of the body as well as by its velocity. So quantitatively, momentum of a body is defined as the product of mass of the body and its velocity. And thereafter we have discussed the change in the momentum of the body. Change in the momentum of a body is final momentum minus initial momentum. Then we have discussed time rate change in the momentum of the body. Time rate change in the momentum of the body is change in the momentum of the body divided by time during which that change has taken place. And as per Newton's second law of motion, this time rate change in momentum of the body is directly proportional to the external unbalanced force. And this change in the momentum always takes place along the direction of the force applied. So using this concept, we have come across a very, very important mathematical formula for force, which is actually the mathematical form of Newton's second law of motion, which is force is equal to product of mass and acceleration. So from that mathematical formula, we have discussed the unit of Newton as well as dyne. These are the SI and the CGS unit of force. So students, I hope you have understood the concepts related to this, and I hope you will study well, watch the video time and again till you understand the concepts clearly, right? So do take very good care of yourself. In the next session, we will discuss the laws of motion, right? Till then, bye-bye, and do take very good care of yourself. Thank you.